grade 10s and welcome to another lesson on equations. Today we're dealing with equations that have more than one term in the denominator. So we're still on equations that involve fractions. I know they're scary, but if you follow a simple systematic process, you will be able to deal with them. Just remember that when there's more than one term in the denominator, you need to make sure that each denominator is fully factorized. So here's an opportunity for you to brush up on your factorization. Okay, first things first. Check to see if the denominators are fully factorized or not, right? I'm sure you can tell that the fraction on the left has a trinomial as its denominator. And how do we factorize trinomials? We write out two brackets, bracket, bracket. We make sure that the last term in each bracket produces the constant in the trinomial. And let me just get my laser. So we're going to factorize this trinomial into two binomials. And on the right hand side, can you see that this binomial has a highest common factor of 2? So my first step is to factorize the denominators. Now that it's in this form, I'd like you to consider something that I will re-emphasize at the end of this lesson. Do you remember the definition, excuse the pun, of an undefined fraction? A fraction that is undefined will have a denominator that is equal to 0. So you need to keep at the back of your mind that a denominator cannot be 0. So what number do you think we would have to substitute into this denominator right here to turn it into 0? Well, this x would have to cancel out with this -4. So do you agree that if we popped a 4 in the place of this x, we would have 2 times 4 minus 4, which would be 2 times 0, which would just be 0, and that would make this entire fraction undefined. Likewise over here, if we substituted a -2 in the place of this x, so basically I'm just looking at the number that's inside the bracket and I'm changing its sign. If we replace this x with a -2, it would take this entire denominator and also turn it into 0, which would make this left-hand side, on this fraction on the left, undefined. So when you're dealing with equations with fractions, I want you to realize that you have to make restrictions. And I've failed to jot that down on this slide, but I will make a couple of points about that at the end of the slideshow again. Anyway, let's follow this process. Make sure each denominator is fully factorized. Done. We've done that in this line. Now you need to create an LCD. LCDs can be quite intimidating if you aren't used to creating them, but it's actually really easy. All you need to do is work from left to right through each fraction and add to each denominator. If let me rather say it like this: if you start off with the fraction on the left, write down its denominator. Then you look at the next fraction. Anything that you see in this denominator that has not yet been written down in the LCD must be written down. So for this LCD, we're going to go left to right. Let's write down x minus 4, x plus 2. And then if I look at this denominator, we already have the x minus 4 written down, so I'm not going to write it down again, but this 2 over here has yet to be represented. So I tag it along the edge. And then I realize, okay, a 2 all the way after those two brackets, it just looks strange to me. So I'm rather just going to pop that 2 in the front. And now it looks nice and neat and tidy, and I have my LCD. The next step is to repeat this line. For the sake of space, I've just repeated the line with a bigger gap on either side of the equal sign so that I can multiply by what I like to call a secret number 1. If I see that this denominator is x minus 4 and x plus 2, what is it missing? What do I need to multiply this denominator by in order to create the LCD? I'm sure you can agree, I need to multiply it by a 2. But what you do at the bottom, you do at the top, because we're not actually multiplying by 2. We're multiplying this entire left-hand side of the equation by a secret undercover number 1. However, In order to multiply the left-hand side, the entire left-hand side of the equation, you have to put brackets. So remember that if you have more than one term in the numerator, like I said in the previous lesson, you must put brackets around it so that when you do multiply by a 2 at the bottom, you also multiply by a 2 at the top, and then in the next step you can distribute this 2 into this bracket. Okay, let's do the same on the right-hand side. This denominator is a 2 and an x minus 4. What does it need in order to generate the LCD? It just needs that x plus 2, right? So let's multiply by x plus 2. But what you do at the bottom, you do at the top. And now I'm going to neaten things up, and in one cheeky step, I'm going to get rid of that denominator completely. I drop it because you are secretly multiplying by the LCD on both sides. So to save some time, you can just drop it. And I've just wedged that 2 up in the front. 2 times 2x minus 5 is equal to, this 1 remains, and I brought that x plus 2 a little bit closer. In my next step, I distribute to get rid of the brackets, and now it's easy peasy grade 8, maybe even grade 7 kind of linear equations. Let's bring all our x's over to one side, all the constants over to the other side. 4x minus 1x gives us 12, 2 plus 10. So if 4 times something gives us 12, then that little something, if 3 times something, 4x minus 1x, 3 times something gives you 12, x must be 4. Beautiful. Simple process to solve this equation, but now I want to ask you, do we have a problem with this answer? Is it perhaps going to make the original equation undefined? I think so. So after all that working out, I'm so sorry to tell you that there is no solution to this equation. You actually need to cross out that 4. But don't worry, it's still important for you to be able to follow this process of dealing with equations with more than one term in the denominator. So the next example is very, very similar. However, in order to save yourself some effort, you need to identify when you can use this cute little trick I'm about to show you. Do you see how similar these two denominators are? The one is y minus 1, and the one is 1 minus y. First things first, let me remind you, when you're dealing with fractions, which restriction should we make? What number do we need to rule out to say, hey, we can't have this as a final answer, otherwise our entire equation is going to be undefined? Do you agree that if y was equal to 1, you would have 0 as a denominator? So we must keep at the back of our minds, and you must jot it down on the right-hand side when you do this exercise for homework, that y cannot equal 1. Now, let's solve this thing and see what does y actually equal to. So, also, don't forget that every single rule you've learnt about equations still applies. So I see that the left-hand side of this equation has fractions, but the right-hand side doesn't. So let's go and turn every single term into a fraction by just popping the whole numbers over 1. So on the right-hand side, we have 1 over 1. Now let's think about our LCD. Remember on the previous slide, I told you, work from left to right. Let's write down y minus 1, and then you write down the next denominator if you have yet to write it down. So you could very well write down as your LCD y minus 1 brackets 1 minus y brackets. However, you'll then take a long way to solve this equation. It might take so much longer than what it really needs to. Let's think about the fact that you can change the order of subtraction if you change the sign in front of the fraction. So let's say that again. Change the order of subtraction, but change the sign in front of the fraction. So we're allowed to take 1 minus y and change it into y minus 1 so that we have a denominator repeating itself. But you're only allowed to do that if you go and change the sign from positive to negative in front of this fraction. Okay, why does this work? Let me just remind you. if you were to factorize a highest common factor of -1, you would change the sign inside of the brackets. And now you have almost integers, -1 plus y. You can flip around and say plus y minus 1. But still, your highest common factor in front of that bracket is a negative. So that's why it's as if you factorized a -1 from this denominator and you made the term in front of this fraction a -1. That's why we change the sign. If you don't get it, don't worry. You can just follow this rule and it will work every time. So it's a lovely, foolproof little trick. So anyway, now you can see that the denominator, that would be the highest common factor of all the denominators, would be y minus 1. So all we really need to do is manipulate the right-hand side. Let's multiply it by a secret undercover 1. What you do at the bottom, you do at the top. And now each denominator is identical, and so I can drop it. 3, I didn't need to multiply by anything because it already had y minus 1 as its denominator. Note that this negative belongs to this 2, so I've written -2, and 1 times y minus 1 just gave us y minus 1. I take my -1 over to the other side. I keep my y on the right-hand side just because it's positive already, so I'm just leaving it on the right-hand side. If you brought it over to the left, that's perfectly fine as well. 3 minus 2 plus 1 gives us 2 equals y. Chuff, chuff, as easy as that. Is this answer valid? Yes, it is, because if this final answer was a number 1, it would be invalid because that is our restriction. So just have a look at what I have to say on the next slide about restrictions and then tackle your homework for the day, which is covered on this slide. Here it is, exercise 4.3, number 1, ABD, FHJL, and the next slide will have more information about restrictions. Just remember, it's something small and easy to forget about, so jot it down, make the notes you need to make so that you can tackle it and remember it forever and ever. Thank you.